throttle is a butterfly valve, housed in a throttle body, and operates by either a cable connected to the accelerator pedal or an electric motor via ECM, and loads by a spring. The throttle body assembly controls the amount of air going into the engine, and locates between the air filter or the air cleaner and the intake manifold of the engine. There are two types of throttling systems used in vehicles. Conventional throttle system, throttle valve is controlled by a cable, and electronic throttle system, throttle valve is controlled by electric motor. The throttle body is directly connected to the accelerator pedal with a linkage or flexible cable, which moves the throttle shaft when the accelerator pedal is depressed. The accelerator pedal is used to control the angle of the butterfly valve, which regulates the amount of air entering the engine. Most throttle bodies are made of aluminum. The conventional throttle system consists of accelerator pedal, throttle cable, throttle body assembly, and electronic control unit, ECM or PCM. The throttle body, TB, contains throttle body housing, throttle valve, throttle lever, attached to throttle cable, throttle position sensor, TPS, and idle air control valve, IACV. A throttle position sensor, TPS, is a sensor used to monitor the throttle position of a vehicle. TPS is usually located on the butterfly shaft so that it can directly monitor the position of the throttle. The contact throttle position sensor, potentiometer, provides a variable resistance according to different throttle valve position. The basic TPS requires 3 wires. The ECM reference voltage, 5 volts, is supplied to the TPS, the TPS voltage signal is supplied to the ECM, and a ground wire completes the circuit. ECM uses the TPS sensor signal as an input to its control system. It precisely controls the best ignition timing and fuel injection timing according to the position of the throttle and the rate of change of that position. An idle air control valve, IACV, literally bypasses air around a closed throttle plate so the engine can get air at idle. According to the signal sent from the ECM, the IACV controls the flow rate of air bypassing the throttle valve during idle. IAC valves are operated by a stepper motor or electric solenoid. IAC stepper motor has a tapered pintle that seats into a corresponding tapered seat. The stepper motor moves a tapered pintle in steps into or out of a matching tapered seat, thus varying the amount of air passing through the valve. As the valve steps increase, more air bypasses the throttle valve. The valve assembly consists of 4 electrical stator coils, a magnetic rotor, a valve, pintle, and valve shaft. The valve shaft is screwed into the rotor so that as the rotor turns, the valve assembly will extend or retract. The direction of valve movement depends on the sequence by which the ECM energizes the coils. Electronic throttle control is the technical name for what is known as drive-by-wire. The Electronic Throttle Control System Intelligent, ETCSI, is a system that uses ECM or PCM to electrically control the throttle valve opening. In electronic throttle control system, the accelerator pedal opening angle is detected by the accelerator pedal position sensor. The throttle valve opening angle is detected by the throttle position sensor, and the ECM uses the throttle control motor to control the throttle valve opening angle to the optimum amount, in response to the amount that the accelerator pedal is depressed. The development of the electronic throttle control system with intelligence enabled better fuel economy, reduced emissions, and enabled safety features. The accelerator pedal position sensor has been mounted in the engine bay and is manually operated by the cable. The accelerator pedal position sensor, which is mounted on the throttle body, is integrated with the throttle lever. The throttle lever is connected by cable to the accelerator pedal. Depending on the vehicle make, these throttle body types may incorporate a magnetic clutch to connect the throttle control motor with the throttle valve. As the driver moves the accelerator pedal position sensor signal voltage to the ECM changes, indicating a new pedal position. The ECM uses the signal to calculate the desired throttle valve angle. The throttle control motor is a DC motor controlled by the ECM. The ECM controls the direction and the amperage of the current through the motor. If there is a malfunction in the system, the ECM turns off the motor circuit, and magnetic clutch if exist, and the return springs close the throttle valve. The throttle position sensor TPS is used to detect the actual angle of the throttle valve. This signal indicates to the ECM that the throttle valve moved to the desired angle. The linkless type electronic throttle control system is the most commonly used, that uses a cable-less system where pedal position sensors are mounted on the accelerator pedal and pedal position information is sent directly to the ECM. The electronic throttle body, ETB, integrates the drive motor which moves the throttle valve, and TPS that is utilized for ECM feedback. Operation of this system is nearly identical to the link type. The electronic throttle control system consists of the accelerator pedal position sensor, electronic throttle body, and electronic control unit. An electronic throttle body, ETB, looks like a typical throttle body. It is fitted with an electronic servomotor or stepper motor and a throttle position sensor, TPS. The electronic throttle body contains throttle body housing, throttle valve, throttle actuator control motor, throttle position sensor, TPS, reduction gears and return springs. The largest piece inside the throttle body is the throttle plate, which is a butterfly valve that regulates the airflow. The throttle body actuator motor is 12-volt DC electric motor. Both power and ground are switched to change the direction of the motor. The motor circuit consists of 4 control transistors on the opening and closing circuits. One transistor supplies power and the other transistor completes the path to ground. This configuration allows the ECM to control the direction of current through the motor. An H-bridge circuit is used to control the direction of the DC electric motor of the electronic throttle control unit. To reverse the direction of operation, the polarity of the current through the motor is reversed. The throttle motor is mechanically coupled to the throttle valve through a gear train and controls the throttle valve angle. Gear train, reduction gears, is used to multiply the torque of the DC motor. The throttle motor pinion gear drives a larger plastic idler gear, which then drives the small gear in mesh with the sector gear attached to the throttle plate. This results in a huge torque increase from the small motor. The throttle plate is held in a default position by a spring inside. The ECM controls the vehicle engine output power using information from various sensors, and consists of a number of integrated circuits and active and passive discrete components. Connectors on the ECM are used to transmit or receive power, communication signals, and sensor signals. The accelerator pedal connector contains 6 pins, 4 pins that provide DC power to the 2 independent sensors, and 2 pins that carry the output signal from the 2 independent sensor circuits. The male connector is attached to the accelerator pedal, and the female connector is attached to the connecting wire harness. The throttle body connector contains 6 pins, 4 gold-plated pins for the signal and 2 tin-plated pins for the power terminals. The male connector is attached to the throttle body, and the female connector is attached to the connecting wire harness.